Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the video where I actually have two bonus problems that are similar to this equation, which you guys can try to solve. Alright, so what I'm first going to do is I'm going to subtract 350 on both sides. So now these two cancel out, and I will have x to the power of 3 plus x minus 350 is equal to 0. Now 350 we can rewrite as negative 343 minus 7. This is equal to 0. Now 343, this is the same thing as 7 to the power of 3. So now I have x to the power of 3 plus x minus 7 to the power of 3 minus 7 is equal to 0. Now I'm going to move I'm going to rearrange this to put this in the form x to the power of 3 minus 7 to the power of 3 plus x minus 7. This is equal to 0. Now if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus 2ab plus b squared. So in this case, this would equal x minus 7 times x squared plus 7x plus 49. This is equal to, then I have my plus x minus 7 is equal to 0. Now if I factor out x minus 7, I get x minus 7 times x squared plus 7x plus 49 plus 1 is equal to 0. Now 49 plus 1 is 50, so I have x minus 7 times x squared plus 7x plus 50 is equal to 0. So now this gives me two equations. I have x minus 7 is equal to 0, and I also have x squared plus 7x plus 50 is equal to 0. Now for x minus 7 equals 0, I can simply add 7 on both sides, so these two cancel out, and I'll be left with x equals 7. For x squared plus 7x plus 50 equals 0, I'm going to be using the quadratic formula to solve this. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this case, a is equal to 1, b is equal to 7, and c is equal to 50. So now I have x is equal to negative 7 plus or minus the square root of negative 7 squared, 7 squared minus 4 times 1 times 50. And I'm dividing this by 2a, so 2 times 1. Now I have negative 7 plus or minus the square root of 7 squared is 49, so 49 minus 4 times 50 is 200 over 2 times 1 is 2. Now I have x is equal to negative 7 plus or minus the square root of negative 151 over 2. Now, I can rewrite negative 151 as the square root of 151 times the square root of negative 1. So I have this over 2. And if you guys already didn't know, the imaginary number I is equal to the square root of negative 1. So I replace the square root of negative 1 with I get x is equal to negative 7 plus or minus the square root of 151 I. And I have this over 2. So this is going to be two solutions. So my three solutions to this problem are, first off, x equals 7, x is equal to -7 plus the square root of 151i over 2, and finally x is equal to -7 minus the square root of 151i over 2. So these are my three solutions to this equation. Alright, so I have x to the power 4 minus 25 is equal to 0. Now 25 here, this is the same thing as 5 squared. So now if I replace 25 with 5 squared, I get x to the power 4 minus 5 squared is equal to 0. Now x to the power 4, this is the same thing as x to the power of 2 to the power of 2. And this is true because if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. And in this case, x to the power of 4, this is equal to x to the power of 2 times 2. So this would equal x to the power of 2 to the power of 2. So now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. And in this case, a is equal to x squared, and b is equal to 5. So now I will have x squared plus 5 times x squared minus 5 is equal to 0. So this gives me two equations. I have x squared plus 5 is equal to 0, and I also have x squared minus 5 is equal to 0. So for x squared minus 5, for x squared plus 5 equals 0, I can first start by subtracting 5 on both sides. So I have x squared is equal to -5. Now I can take the square root on both sides, so I have x squared is equal to the square root of -5, so these two cancel out, and I will be left with x is equal to plus or minus the square root of -5. Now, the square root of -5, this can be written as the square root of 5 times the square root of -1. And if you guys already didn't know, the square root of -1 is equal to the imaginary number I. So now this will give me x is equal to the square root of 5i, plus or minus. So this is our first two solutions to this problem. Now, for x squared minus 5 equals 0, I can simply add 5 on both sides. These two cancel out, and I'll have x squared is equal to 5. Now I can take the square root on both sides, so I have the square root of x squared is equal to square root of 5. So these two cancel out. Now I'll be left with x is equal to plus or minus the square root of 5. So my four solutions to this problem are the square root of 5i, negative square root of 5i, the square root of 5, and negative square root of 5. So these are my four solutions to this problem. So now the first thing I'm going to do is I'm going to subtract 2 on both sides. So now I'll have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, x to the power of 6 here, we can rewrite as x to the power of 3 times 2. Now, remember, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 3 times 2, this is going to equal x to the power of 3 to the power of 2. minus x to the power of 3 minus 2 is equal to 0. And now I'm going to let x to the power of 3 equal to y. So now if I substitute in y for x to the power of 3, I get y squared minus y minus 2 is equal to 0. Now, we can simplify this. So what two numbers multiply to get negative 2 and add up to get negative 1? Well, that's going to be negative 2 and 1, right? So now we have y minus 2 times y plus 1 is equal to 0. So now this gives me two solutions, or two equations. I have y minus 2 is equal to 0, and I have y plus 1 is equal to 0. So for y minus 2 equals 0, I can simply add 2 on both sides, and I get y is equal to 2. So this is one solution. And for y plus 1 equals 0, I can simply subtract 1 on both sides. These two cancel out, and I have y is equal to negative 1. So this is another solution. So now remember how we let x to the power of 3 equal y. So if x to the power of 3 equals y and y equals 2, then I have x to the power of 3 is equal to 2. And to solve this, I'm going to take the cube root on both sides. These two cancel out, and I'll be left with x is equal to the cube root of 2. Now, for y equals negative 1, I have x to the power of 3 is equal to negative 1. Now, if I take the cube root on both sides, these two cancel out, and I get x is equal to the cube root of negative 1 is simply negative 1. Now, we are not actually done yet, because if x to the power of 3 equals negative 1, we can actually find another solution to this. So if x to the power of 3 is equal to negative 1, I'm going to first start by adding 1 on both sides. So now I have x to the power of 3 plus 1 is equal to 0. Now 1 here, this is the same thing as 1 to the power of 3. And if I have something in the form a to the power of 3 plus b to the power of 3, this is equal to a plus b times a squared minus ab plus b squared. So x to the power of 3 plus 1 to the power of 3, that's going to equal x plus 1 times x squared minus x plus 1. So now this gives me two equations. I have x plus 1 equals 0, and I have x squared minus x plus 1 equals 0. So for x plus 1 equals 0, we simply subtract 1 on both sides, and we get x equals negative 1. And this is the solution we already got. Now, for x squared minus x plus 1 equals 0, we are going to be using the quadratic formula to solve this, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So in this case, a is equal to 1, b is equal to negative 1, and c equals 1. So I have negative b, so negative 1, plus or minus the square root of b squared, so negative 1 squared, minus 4 times a times c, all over 2a. Now negative and negative 1 is positive 1, so I have positive 1 plus or minus the square root of negative 1 squared is positive 1, minus 4 times 1 times 1 is simply 4, over 2 times 1 is 2. Now this gives me x equals 1 plus or minus the square root of 1 minus 4 is negative 3 over 2. Now the square root of negative 3, we could rewrite this as the square root of 3 times the square root of negative 1. And the square root of negative 1, this is equal to I. So now I have x is equal to 1 plus or minus the square root of 3i over 2. And these are going to be our two other solutions. So my three solutions are x is equal to the cube root 2, x is equal to -1, x is equal to 1 plus the square root of 3i over 2, and x is equal to 1 minus the square root of 3i over 2. So these are our four solutions to this equation.